Now this chi-square test of two proportion. You should remember one thing in this, that it is applicable only for certain type of study design. And what those study design are, that we will see. So we have learned chi-square test of goodness of fit. Chi-square test of goodness of fit, we take only one proportion and we test the proportion of the categorical variable, the levels of categorical variable against a known standard or against a hypothesized proportion. So if there is a known proportion is there, then we enter those known proportion. Otherwise, we hypothesize, we assume it to be equal. Second, we learned the chi-square test of association, where we made n by c contingency table and 2 by 2 contingency table, and we saw the underlying assumptions. The third is the chi-square test of two proportion, and in this also we will go by the similar flow. Like first we'll learn the basic concepts, then the research questions, assumptions and hypothesis, commands and interpretation, and then the summary of the commands. So this chi-square test of two proportion is that the first thing is there should be two independent group. In all other cases, we have recruited the individuals and then we have categorized it. In this case, you will have two populations since beginning. And in this case, you study the binomial proportion. That means you cannot have polynomial proportion. You will have only two proportion of a dichotomous dependent variable. And this is also called as the chi-square test of homogeneity. So the concept, what is this concept of binomial proportion? So now you have recruited 50 males and 50 females. And again, I said that they should not be paired, means they should not be 50 couples. You should recruit 50 from a different sample and 50 females from a different sample. And then if 4 females had a history of heart attack out of 50 males, sorry, I think males and females, there's a typo error. Read this as a female. In this case, it is a female and this is as a male. And then again, the proportion of females having heart attack, it is 4 by 50. So it will be 0.08. Similarly, the proportion of males having heart attack will be 8 by 50. So it will be 0.16. Now, what will be the other proportion? So having something and not having something. So not having something would be 46 by 50, or you can deduct 0.08 from 100. So 92% will be the proportion of females not having heart attack. Similarly, 84% will be the proportion of males not having heart attack. This is the binomial proportion, where you have got two proportions. First is the proportion of having a particular interest, outcome of interest, and the second will be the proportion of not having that particular outcome of interest, which is in this case is the heart attack. Now, what are the research questions which we can apply for this chi-square test of two proportion? So if you want to know whether the proportion of BMI categories, here I have only two categories of BMI, normal and high, of MBBS student of AIIMS Patna and AIIMS Delhi. Is it equal? So I have the second, whether the surgical site infection rate, and that surgical site infection rate again is categorized as present or absent of two units. It can be unit 1 and unit 2 of surgical department, whether it is equal or not. So I have got two different sample size, that means surgical department 1 and surgical department 2. And I want to compare the proportion of a surgical site infection rate. Again, this is a binomial proportion because there will be surgical site infection and there will be absence of surgical site infection. And the third is like whether the proportion of COVID cases in rural and urban population is equal or not. So these are the research questions for which I will use a chi-square test of two proportion. So in all these research questions, what have you observed? That there is a proportion of various categories of a nominal variable, and we want to test it across the different population. So the appropriate statistical test for such type of research question is chi-square test of two proportion. So in case, just to differentiate between the chi-square test of association and chi-square test of two proportion. So in case of a chi-square test of association, you start with one population and then you look for the association between the two categorical variable. Like maybe you take samples from a single population and you compare like presence of diabetes and maybe the obesity present or absent. So this will be chi-square test of association. But if you take two different populations, you take one sample from non-obese and you take another sample from obese, and then you look the proportion for this diabetes present in non-obese and obese, then it will be the chi-square test of two proportion. So the underlying assumption in this case will be one independent variable and one independent variable, both should be measured on the dichotomous level. There should be independence of observation, which we have discussed, and it is used only certain type of study design. It is not a very commonly used test. Most commonly used test is the chi-square test of association. The other two, goodness of fit and two proportion, that is less commonly used. And then in this case also, expected cell frequency should be greater than 5. So the null hypothesis is that the population proportion of these variable of interest is equal in those population, and they are not equal. So chi-square test of proportion can be used in these two type of research design. We have discussed that. So we will take group 1 where we can define it as a diabetic and non-diabetic. Like maybe you can take one population of AIIMS Patna and one population from IGIMS, the medical students. And if you want to see how many medical students are diabetic and non-diabetic in one population and the other, how many diabetic and non-diabetic. And if you want to compare these two proportion of diabetic in two groups, then you can apply chi-square test of two proportion. Or if a single group is there, but you have assigned two different intervention, like in first case, you have given drug A, maybe after some time, washout period, you have given drug B or any other intervention. And if you want to compare the outcome in both these two, intervention 1 and intervention 2, then you can use this chi-square test of two proportion. Now let's see how to demonstrate this. So the question which is there for this chi-square test of two proportion is, so I want to know whether the proportion of male and female COVID cases in type A and type B hospital is equal or not. So we have created this data of type A and type B hospital arbitrarily because this was not the data set. This was not present in the data set, because the data set I have explained in the first session, which we are using, that is the 180 data of the COVID patients who were admitted in the AIIMS Patna. And we have taken the 180 data out of that total 1700 data. But this we have added like type A and type B only for demonstration purposes. So let's go back, so that there will be a type of hospital and there will be male and female COVID. So maybe I will put this back to this variable window. And in gender, you can see this. So gender will be an independent. In this case, male and female, I have to say, so this will be this gender. I will shift this into the column. In this case, it is the dependent variable because I have to see the percentage of male and female cases. And in rows, it will be the type of hospital. So maybe the hospital type, if I see outcome oxygen admitted, let me see. This is the hospital type, maybe A and B. So now you can see maybe expected cell frequency, it is more than in all the cases. But in this case, instead of chi-square, you have to click this Z test of difference in two proportion. So if you click this Z test of difference in two proportion, you can see this. Obviously you can leave. And then you can see here this value. So you can see here, this is the 67% are in type A hospital, 67% are male and 33% are female, whereas in type B, 78% are male and 21% are female. So you can say that there were more male patients in type B hospital and there were more female patients in type A hospital. And this was not significant. You can see here. This was not significant. So if it is not significant, we are not going to comment on Kramer-V. And this is how you take. Even if you click here, the chi-square, this one. So this also, if you click, many a time you see the value in this case, it will be different. You can see the chi-square value is different. Although the p-value is same, but the chi-square value is different. So many times by mistake, we have seen people doing this chi-square test of association instead of this chi-square test of difference in two proportion. But in this case, if such scenario exists, in that case, if there is a binomial proportion and if the two samples are taken independently since beginning, and if you want to compare, then you should use this chi-square test of two proportion. So how will you write your interpretation? So for writing interpretation, this is the way you can go down. This was for the more than 2 by, this was for the goodness of it, and this was for the categories. So you can so this was for the not. So it's, you can the 2 by 2 will again like category A and B and then proportion of these values, and you can write whether it was higher or lower in one, like it is higher in one population as compared to other or lower in one population as compared to other. So this is how you have to write